morning everybody. Department of IEEE France Xavier Engineering College, Tirunelveli welcomes you all. Electrical and Electronics Engineering Department was started in the year of 2002. The department is functioning with two PG courses such as Power Electronics and Drives was started in the year 2011 and Power System Engineering was started in the year of 2013. We got recognized research center status from Anna University Chennai in the year 2017 and our department reaccredited by National Board of Aggregation, New Delhi from 2017. The department has a strong faculty strength who are committed and are specialized in various streams of electrical engineering. Also, we have DST, FIST supported Advanced Power Electronics and Drives Laboratory and National Instruments Powered LabVIEW Academy.
Let us rejoice and be glad in it. Good morning to and all present here. It gives me the immense pleasure to welcome you all on this webinar session under the topic Wireless Sensor. This webinar is hosted by the Department of Electrical and Electronics Engineering of Francis Xavier Engineering College, Tirunelveli. On behalf of our chairman, Dr. S. Cletus Babu, our managing director, Mr. Arun Babu, and our general manager development, Dr. Jayakumar, and our beloved principal, Dr. Vel Murugan, and our beloved HOD, Dr. P. Annapandi, I welcome all the heads and faculties from various institutions and the alumni of FXCCE. My most hearty welcome to Dr. V.JAWAHAR Senthilkumar, our resource person. Now, at present, he is working as a professor at Anna University in Chennai. He has a teaching experience of 15 years. At present, he guiding 4 PhD scholars. In past, he guided 6 PhD scholars. He published 29 international journals and 6 national level journals. Now, I welcome Dr. V.JAWAHAR Senthilkumar to present a webinar. Thank you.
Good morning, everybody. I'm Dr. Jawahar Senthilkumar, working as a professor on Department of Electronics and Communication Engineering, College of Engineering, India, Anna University. I'm giving this webinar on behalf of Francis Xavier Engineering College on the topic wireless sensor networks. So I'm going to explain what is this wireless sensor network and what are the applications of it and what are all the basic needs for this wireless sensor network and how it was formulated. And we all know that the Adhoc networks is the mainstream and how it was differed from this Adhoc network and what are the do's and don'ts in this case and this wireless sensor network, how it is important and all those things. So we can move to the slide presentation. Today we are going to see about the wireless sensor networks. I'm going to present the hardware components. So as all we know, IEEE is entitled to give the standards for mobile, Adhoc, and all the other features. So this IEEE 802, we are all well aware of. So this IEEE 802 is a working group which is formulating the standards for Adhoc network and its related operations and also for the wireless sensor network as such. So this IEEE 802 is a working group which is having so many subgroups in this case. As I showed here, it is having so many subgroups. So starting from IEEE 801, which is concentrating on the LAN protocol, because that was the first evolved one, which is a LAN network. So IEEE 802.1 concentrates on the LAN protocol. And 802.2 is a logic link control, LLC. And 3, as all we know about 3, 4, and 5, because that is a more pronounced IEEE standard. IEEE 802.3 is Ethernet, IEEE 802.4 is bus, and IEEE 802.5 is ring. Similarly, it has all the other standards also, but I listed some of the main standards, which is 11 concentrating on WLAN, that is the wireless LAN, and IEEE 802.15, which is the WPAN. So this WPAN is wireless personal area network. So this personal area network is having standards about the personal area, that is within a particular region. All the Bluetooth, Zigbee, and even the wireless sensor network, what we are going to talk about now, is also coming in this particular IEEE 802.15, which is WPAN. And similarly, it is not stopped over there, and it is list is very lengthy. 16 is for broadband wireless access, and so on. This IEEE 802.15, within this IEEE 802.15, we are having a special task groups. So this task groups is going to take care of a particular uh, function or particular action what it has to do. So let me see this task group 1. So this has to be called as IEEE 802.15.1, which is a task group 1 within 1.5. So this task group is going to take care of the Bluetooth activities, defining the physical layer of the Bluetooth, defining the MAC layer of the Bluetooth, uh, specification for wireless connectivity, and everything is going to be happen in this task group 1. And as shown here, this is going to operate on, that is personal operating space, POS, is 2.4 gigahertz. So this 2.4 gigahertz is the operating frequency for this WPAN, also that is including Bluetooth, Zigbee, and also the wireless sensor networks, WSN, are what we are going to talk about. So the task group 2 is about the coexistence. That means once it evolved from Bluetooth to another activities, or otherwise with the WLAN, we have to communicate with, because it is a personal area network which is having a smaller region, and if the data is collected in that particular smaller region, that is personal area network, it has to be transmitted to the wireless LAN. Then only it will be get connected to the internet or the cloud, whatever it might be. So there should be a transfer of data from WPAN to WLAN. So there should be an interoperability of this particular data which is created in WPAN to WLAN. So this interoperability, that is coexistence of this data, is taken care by the task group 2. So works on the interoperability between the WPAN and IEEE 802.11, which is WLAN. The task group 3 works on the high data rate WPAN. So normally if it is a small region data pan, that is a Bluetooth or Zigbee, the data rate is going to be smaller, is lesser. So this task group 3 is working on the high data rate in WPAN, how it is possible, what are the things we have to change, and how we can achieve a data rate to 110 Mbps, and so on. Okay, so this group is working on the high data rate of the WPAN. Why it is needed? Because as of now, we started talking about the 5G networks. So we are moving to the 5G. Once it is 5G, everything will be speed, and this WPAN network should also cooperate with the speed of the 5G network. So this task group 3 is working on WPAN operate at a data rate more than 20 Mbps to 110 Mbps. And this task group 4 is especially for the WSN. Works on ultra low complexity and ultra low power. This is the catching feature of WSN. So we are going to see in the later slides that this WSN is going to have a very low energy. So this low energy or energy constraint is the main portion to be talked about in WSN. So this task group 4 is working on ultra low complexity, ultra low power, and ultra low cost physical and MAC for the data rates. And it includes so many data rates, and in which we are having this 2.4 gigahertz frequency. So that is also coming under this task group 4. So this task group 4, that is IEEE 802.15.4, which is going to address the WSN activities. So this is a normal technology development which I listed here, but it is not stuck to this particular years. Just I bunched it into 10 years as a decades. Okay? It's not exactly to this particular years. You should not consider this as in 2000 wireless networking was there, WLAN was there. It is there in the peak, like that you have to. In 1990, if you have 1990s, computer networking was given, and LAN and Ethernet are the main topic of the talk. Similarly, 2000, the main topic of the talk is this WLAN and GSM. And similarly, in 2010, WSN, MEMS, and cloud are the main topic of the talk. But even then, I listed WSN in 2010, but exactly it is not found on 2010. In early 2000 itself, there is a talk about wireless sensor network. Normally, in almost all the cases, I used to admire this because in 1996, I think, okay, in 1996, there was a release of a particular movie which is called to be Twister. I happened to see that movie in my college days. That movie Twister is about a storm chasing people, a set of researchers who are chasing the storm, Toronto, as we call them. Okay? So they're chasing a Toronto, and what this researcher trying to do with the Toronto, they are trying to insert a small ball-like sensors into the core of Toronto. This is the movie. When it is published, when it is screened, it is screened in 1996. So in 1996 itself, the film industry have a concept of having a small sensor nodes which can be inserted in the core of the Toronto in such a way that once it was inserted inside the Toronto, okay, inside this storm, then every tornadoes will be activated and they will be communicating with each other, and they will be giving the signals out of it, and we can know about how this storm is moving, in which direction it is moving, how strong it is, what is the length, everything can be measured. Okay? So this tornado is measured with the small sensing elements, which is the wireless sensor networks. So in that time itself, they had a concept of it, but it was slowly evolved, and it has its own. In 2003, and all the group is formed, the task group is formed, and after that, so many standards were evolved, and in 2010 and all, everything everywhere was started talking about WSN. So I listed in this case of wireless sensor network in this place. So as we know, this is evolved from Adhoc network. There is no much difference between the Adhoc network and wireless sensor network. That means both are almost parallel, but it has its own differences in some key points. Now we can see what are the likes and differences of Adhoc network and wireless sensor network. So the comparison of Adhoc network and wireless sensor network. So what is the type of network? What type of network is this? So if you see in this case, if you take the Adhoc network, the network is heterogeneous. That means it will have different types of communication modules in this case. But in the case of wireless sensor network, it is a homogeneous network. It is having a group of nodes of same kind. It is very uniformly same nodes as such. It is a homogeneous network. And the traffic pattern, which is important, because then only we can able to design the traffic rules and all. So the traffic pattern in Adhoc network, it is a point-to-point communication. So there will be one particular source and there will be one particular destination. And this source and destination are having unique IDs, and this source will create a data and it will be directed towards the destination, and everybody knows where the source is and where the destination is. It is a point-to-point communication. But if you take the wireless sensor network, it is any to any, many to one, many to few, one to any, whatever it might be. So it has the entire set of nodes, and each node should be considered as a source, and each node should be considered as a intermediate node towards a sync node. So everywhere, everything might be happening in the wireless sensor network. So coming to the data rate, so whether this decides how much of bandwidth it requires and everything. So what is the data rate? In Adhoc network, the data rate is very high because it's going to give a particular file, a particular message, whatever it might be. But in the case of wireless sensor network, the data rate is very low. That means either it may give you an answer whether the event has happened or not in the terms of yes or no. That's all. That data is going to be there. If not, with some values. So the data rate in wireless sensor network is very low. So use of network. Okay. So in the case of application, this Adhoc networks is application independent network, and the wireless sensor networks are application dependent network, because if some of the nodes were deployed in particular region, all the nodes will have a specific function, a particular application. That application might be sensing the temperature over that region, or sensing some what can I say, movement of animals, movement of persons, or whatever it might be. So these sensor networks are application dependent. I think it is application dependent network. Okay, so in this case it is application independent. It has to be changed. Okay, so network support, in this case support common service, and it supports specific application here. So it is application specific network. Okay, so it should not be independent. It should be dependent in that case. Okay, so it in this case it is a dependent, application dependent in this case. So because the network supports specific applications as such. So addressing, this is very important in this case. The addressing means in Adhoc networks, each and every node will have a IP address. It will have a unique IP address for itself. But in this case of wireless sensor network, the nodes will not have any unique IP address, but instead it may have a logically unique MAC address, or others a spatial address. So it will not have a unique IP address in that case. So the routing protocols, in this case it is hop by hop, and this here it is data centric protocols or location centric attributed based protocols. And the host used, or in Adhoc networks it is independent. In wireless sensor network it is collaborative use. Number of nodes in Adhoc network it is limited, because it's going to be a known number of Adhoc nodes. In the case of wireless sensor network, it is more in number. Even in a particular region, you might have more than thousands of nodes, and you may not know whether all these 1,000 nodes are going to take part in particular communication at particular time period. So in time periods, this will vary. So the sensor network, it will be more in number of nodes. And nature of host, nature of nodes, In the case of Adhoc network, this is a very important feature difference between the Adhoc network and wireless sensor network. In this case, the Adhoc networks are attendable and battery powered with recharging capability. This is the very important point in that case. So this Adhoc nodes are attendable nodes because it will be a person held handheld devices in the case of, okay, the Adhoc network nodes are handheld devices, so that can be attended, and the battery power with rechargeable capabilities as we have our cell phones in our hand. But in the case of wireless network, and these networks are not handheld devices, it is deployed in even unmanned situation, even the places where man cannot go in. So this places the Adhoc wireless sensor network is scattered everywhere. So this is not a handheld, this is not a rechargeable capability nodes. So it is self-configurable, unattended, battery powered with limited capabilities, recharging capabilities. That's all. If at all, if it is enhanced with energy harvesting, it can recharge itself. Otherwise, it is not rechargeable. So because it is deployed in a unmanned region also. So this is the difference between the wireless sensor network and the constraint between the wireless sensor networks. And the MAC protocol, here it is efficient resource assigned protocol. QoS under mobility, and here it is to establish communication links for data transfer to share communication resource efficiently. Right. Now we gave a difference between Adhoc network and the wireless sensor network. And what really the wireless sensor network look like? What is a wireless sensor network? So if you take this wireless sensor network, it is very clear that it has three terminologies: wireless, sensor, and network. So definitely there are sensors. Okay? Definitely there are sensors. As in the previous slides, we should come to a conclusion, and right now we should understand that the sensors are small in size, and these sensors are self-operative. The sensor should have all the capability within itself to act like a sensor or as a transferring element. So these are small sensors, and it has to work as a network, and even it has to work as a network in a wireless mode. Okay, so the sensors operating as a network in a wireless mode is the wireless sensor network. So we have the network. So this network should have the capability of self-organizing, power hour, as we know, the important feature that it cannot be rechargeable. So it should live with a small power which is given to it. So it should be power aware, and it should take care of the communication, whether it is hop by hop or single point, whatever it may be. Okay? So it consists of a network, and the embedded system is coming into the picture with small untethered processing, the storage and control. All these parts are taken care by the embedded system. And the MEMS, which is used to the production of the small size nodes which are capable of sensing. Okay? Once it wants to sense, it should consist of the sensors. So all the types of sensors and actuators has to be there inside the sensors. So it should be a short range, or sensors and actuators should be there. So MEMS give the solution for this. So these different entities will come into a part, and they will form a wireless sensor network. And the properties of wireless sensor networks. So why these wireless sensor networks are used? It is used mainly for information collection. So as we said, it will be solved. I can use this word. It can be solved. That means it can be deployed in a remote location where human cannot intervene. Human cannot go very frequent. Okay. So that might be the places. Even you can take some atomic power stations, or you can take some dense forest where you can deploy this sensors, and you can sense the activities of some endangered species animals like that. So you cannot very frequently enter to that forest, and you cannot view what this endangered species is going to do in that particular place, or whether it is moving here and there, or you cannot go and see all those things very frequently. But we can deploy this sensor nodes in such a way that this will give you the data about the species of entrance. Or even if you take a very crucial activity like military, you can deploy the sensor nodes in the line of control, and it will be in shadow. It will be not known to everyone, but it will sense any movement in the border, and it will inform you and there is any movement if in case. So mainly for information collection, and it is a single owner because it's going to deliver its data or collected data to one particular base station. So probably it's a single owner, and this is the number. It will be up to hundreds of thousands of nodes. So in a particular region, you may be deploying thousands of nodes in that case. Why we have to deploy thousands of nodes? Why cannot be particular number of nodes in tens, or some number of tens in that case? Because the one thing is, it is having a limited power capability. So there is a possibility that one particular node which is sensing continuously is going to deplete its power, and it is going to worn out. It's going to die in that case, right? So if it has happened, the next sensor will take care of that uh, action in that case, because it is not very easy to go very frequently in some places, but we have to monitor continuously. So if you take a chance of moving into a particular region, and possibility of placing sensors, you will be placing in plenty, so that if one sensor fails, another sensor will take into action, and it will give you the data. So you will be getting the data for a longer time period, years together, as we say. Okay? So we will be having hundreds of thousands of nodes in that case. So it is a bounded direct stream. So from a particular source to link. So the data will be transferred from a particular source or the source to a link. It is a bounded directed stream. Limited computation capability. So this coming to this computation capability, wireless sensor network are not a computational capability nodes. That means whatever the data it sends, it will not compute anything. It will not, what can I say, do a math. It will not do any particular equation solving within that node. That capability is not given to this wireless sensor network nodes. It has a limited computational capability. At least, if at all, if it has a computational capability, it has to compare. It will be stored with one particular value. Let it be a temperature sensor element. It will be uh, stored with one particular temperature value, and it has to sense the temperature value of the environment. And if the environment temperature value is more than what is stored, then it has to trigger the transmission mode. Okay, even it can be used in the telemedicine. It can be used in to uh, monitor the vital uh, things of a patient. Okay, so it can be used. So you will be stored with one particular value, and even the pulse rate, let it be. So the pulse rate will be stored with a particular value, and it will monitor the patient's pulse rate. And if the patient's pulse rate is more than that limited value, threshold value, then it will send a data to the concerned doctor might be a sink, whatever the person has to be transferred. Otherwise, if the sensed value is not above the threshold, it will not give any data. So the computation capability of these nodes are very limited. And similarly, the limited communication capability. So it will not transfer all the data what it is going to sense. Okay, it will sense only the data which is available, and it will not it will not send a list of theories about the data which is sensed. Okay, it will give data that is whether it is more than that or not, or otherwise, if at all, how much it is more. Like that, it has to give. So it is a limited communication capability. And limited power resource, we all know, because it is going to live on a value of battery. In most efficient case, it will be of 2 AAA size batteries. That's all. So it has to live on this 2 AAA size batteries for its lifetime. So it will be working on limited power source. And the node may not have unique ID, as we already discussed. It is not having any unique IP. In common case, these nodes are stationary. In common case, these nodes are in stationary, because you are talking about a very low powered node. If you give an actuators to move this node from one place to another, all the energy which is given to it will be drained in this case itself. So mostly these nodes are stationary nodes. In some cases, according to some application, we are having some movable nodes also, but in most of the common case, it is a stationary node. So requirements. What are the requirements for the WSN nodes? So the requirement is a varying network size. That means it should be scalable. So it should be capable of operating with 10 nodes, and it should also be capable of operating with 10,000 nodes in a particular time period. So it should be scalable in that case. Inexpensive node equipments, as these nodes are to be solved in plenty, so it should be of minimal in value. We cannot afford to lose an heavy cost sensor nodes. Okay, it's not possible. So it should be inexpensive. Long lifetime. It's what can I say? It's a contradiction, I have to say. So we are giving a limited power, but we are expecting to have a long lifetime with that limiting power. So we are expecting it. But this can be achieved by having a protocol changes in that case, so that a protocol is more needed in this case. Okay? So even then, the battery power which is given is very limited, but we have to effectively or wisely use that battery power whenever required and only whenever required, and extend the long lifetime in that case. And the load balancing should be there, and load balancing is a very important feature to be talk about, because if you deploy 100 nodes in a particular region of particular area, if one particular set of nodes alone is going to communicate about that region, then what will happen? That particular set of node in that particular region alone is going to be get deployed in the energy, is going to be depleted in the energy, and it is going to fail in a nearer future. Once, if that particular region, that particular nodes is failed, that particular region will be called as a black hole. You will not be able to sense furthermore in that particular region. So that should not be happen. So the load should be balanced equally. If there are a particular n number of nodes in a particular region, all the n number of nodes try to live as long as possible that network exists. No node should fail before the network exists in that case. So every node should have a balance. That load balancing feature should be there. Self-organization, it has to be self-organized. And sensible data aggregation, as we know, it will be having a limited computation capability. So sensibly it has to aggregate the data, otherwise it has to unnecessarily waste its energy in repeated data, sending the repeated data. So aggregation is a must. And consolidation of redundant data, what I explained in the last comment itself. So the consolidation of the redundant data is much needed to aggregate the data, in aggregating the data and to give a consolidated value. And possible mobility. So this is the last feature requirement, very specifically for some specific applications. If not, this feature will not be there. So possible mobility. And this is the general architecture of the WSN. So if you take in this case, it is connecting the real world. Why it is connecting the real world? Why I'm calling this as connecting the real world? Because it is sensing the parameters of the nature, whether the temperature of the nature or the vibrating action of the nature. You can have the sensor node. You can think like this. You can plant n number of nodes in the seabed. If the seabed vibrates, with the value of its vibration, you should be able to tell whether it will create a tsunami or not. So that the case, the sensors are directly in contact with the real world. Okay? So it is monitoring the real world. It is sensing the real world. So the sense unit, the sensor unit is connecting with the real world, and whatever the data it connects, it collects, which is given to analog to digital ADC. So because whatever the value which is going to sense is an analog value, so it is converted to a digital value, analog to digital converter ADC, and it is giving to CPU. You should not think when it is called to be CPU like Pentium 4 or so. It's a low capability or enough capability CPU. So after it is aggregated in CPU, it will be given to a communication unit. Even then, I gave a very big antenna here. Your sensor nodes are not going to have this much of big antennas. It's just a small antenna to capable of transferring with hundreds of feet in that case. Okay. So a communication unit which will transmit the collected data, aggregated data, processed data to the user. And it need not be always a sync. Okay, it need not be always a sync, because a particular node which will be far away from the sync, far away from the base station, may not able to, definitely it will not be able to communicate directly to the base station. The node has to give its data to the nearby another node. So that node should receive the data from the nearby node, and it has to give to the another node. So this will be a hop by hop transmission, and finally it will reach the sync in that case. So the challenging factors, I'm listing out the challenging factors in having a network, the wireless sensor network. So the node deployment itself is a challenging factor. How we are going to deploy the nodes, whether we are going to throw it, whether we are going to dust it from the helicopter, aircrafts, whatever it might be, or we are going to place it in a particular locations. So the deployment itself is, because if it is a normal place, even a human can sense it, but this are the nodes which are going to work on some remote places where human cannot intervene very frequently. So the deployment itself will be a difficult challenge in that case. Energy consideration, we always, in each and every slide, whatever the slide which is there for wireless sensor network, definitely one point will be for energy consideration, because that is the foremost consideration. Okay, so it will be a repetition, but it will happen. It will be there in every slide. Okay, so the energy consideration, the data delivery mode, the fault tolerance, scalability, network dynamics, transmission media, connectivity, coverage, data aggregation, the quality of service, and so on. Okay, so these are the challenging factors. So these are the uh, we can say these are the questions how it is going to happen, and we have to get the best suited answer for this. Coverage, it's a question. Let us have this as a question. Okay, so how it is going to get the coverage? What is the limitation? Then we have to give the answer in that case. So coming to the node deployment. So what is node deployment? We know how we are going to place the data. So it is an application dependent, purely application dependent. If it is going to be in our territory, even we can go in person and place the data in that case. But if it is going to be a territory of another person, okay, definitely we cannot intrude and we cannot go inside and place the data in that case. So definitely we have to throw some sensors from the place somewhere else nearby. Okay? So either it is deterministic or randomized deployment. In deterministic deployment, the sensors are manually placed and data is routed through predetermined path. So this can happen in the line of control. If you consider this as a line of control, LOC, then you can deploy each and every sensors in each and every poles. And if there is any unwanted vibration on those sensors, then we should know that somebody is hitting that particular line of fence, that LOC fence in that case. So it will give you a data in that case. So it is deterministic in that case. In some cases, we'll be having random mode deployment, like deploying the nodes in the seabed. So we cannot go to the seabed and place all the nodes. You will be here and you will be here. Like that, it will not be possible. So we have to throw the nodes randomly in that case. So the in random node of deployment, the sensor nodes are scattered randomly, creating an infrastructure in the Adhoc manner. It will be creating by its own because it is self-organizing nodes. Okay, the nodes are self-organizing node. That is the capability of our sensor nodes. So it will be organizing itself. So it will know where the neighbor will be, and it has to be organized themselves in that case. So energy consideration. Okay, so we know that it is a limited energy consideration, and in this case, so computation will take some energy, and transmitting information will take some energy. So transmitting information, it's a must, it has to be there, and commutation can be limited in that case. Okay? So like that, we have to have a trade-off. In multi-hop WSN, each node plays a dual role. As I said, each and every node will be a sender and each and every node will be a router. It will be a source and it will be a receiving element to the next router. Okay, so it will be a sender and it will be a router. So this is the energy consideration. Data delivery mode. Okay, this is also an important one. So time driven data will be there, event driven data will be there, and query driven data will be there. So this is the three major activities in that case. So if you have a time driven, there will be some sensors in which it will sense the data periodically, suitable for application that requires periodic data monitoring. Okay? So this will sense the data periodically. So it will sense uh, in a particular time period, it will sense the data and it will give you the report in that case. It will give you the data values in that case. It is a time driven continuously. It has to sense year long. Let me take a data, what can I say? A value of the temperature has to be sensed in a particular time period of every day. Then you will be having a data time driven data, continuously sensing data. Event driven. In some cases, you can think like this. Okay, you want to monitor a movement of an endangered species, an animal. Okay, an endangered species. So you are placing some sensors. So what the sensor will do? Most of the time period, the sensor will be silent, because only when, if it comes to know that that particular animal crosses that particular place, then it will give you a data. Okay, so it reacts immediately to sudden and drastic change, whatever that might be. Okay, so whenever, even for the tsunami case, okay, it will be silent. It will be sensing the value and it will be silent. Only when the seabed vibrates for more than threshold value, it will give you the data. It is an event driven. So what event has happened? In one case, that particular animal crossed that particular line. That is an event. In another case, the seabed vibrate more than a threshold value. That is an event. So this is a event driven data delivery mode. And query driven, in this case, it's very limited, but in some of the cases it will be there. So it will respond to a query generated by a base station or another node. So in some cases, even we have a protocol, which is direct diffusion protocol, in which we'll be having a query driven protocol in that case. So in this case, we'll have a query in that case. So respond to a query generated by a base station. Base station can ask a query and it will respond at that particular time period. What is the temperature? What is the humidity? And whatever the values it might be in that case. It's a query driven. And also we can have a hybrid of this. Either the data, the nodes might be a event driven node. Okay? It might be a event driven node. But if you want to check, because it's going to be there silent for a longer time period, if the base station wants to check what might be the data right now, to check whether the node is checking properly or not, sensing properly or not, it can give the query driven. So the same node is act as a event driven and also as a query driven. It's a hybrid mode in that case. The routing protocol is highly influenced by this data reporting method. So only when the data reporting method is fixed or chosen, the routing protocol has to be chosen in that case. The fault tolerant, we already explained about this. The nodes may fail or be blocked. That might be because of lack of power. In some cases, it is physically damaged, because mostly these nodes are deployed in very crucial situations. In that case, if you want to sense about a volcano, okay, you can sense an active volcano. What will you do? You will throw some sensors in that volcano, the mouth of the volcano. In most of the cases, the volcano will be very silent. In some cases, if the temperature is rising beyond, okay, the data might be reached you, but what will happen to the sensor? The sensor will be physically damaged because of the temperature in that case. So that might be happen in that case. So the node may fail or be blocked because of the lack of power, the physical damage, environmental interferences. In all these cases, it may fail. But even then, if one particular node fails, it should have its own arrangement to take care of the data to be delivered to the base station, or some arrangement. That means the fault tolerance mechanism should be there to sense the data continuously, requires regularly adjusting transmission powers and signaling rates on this existing link to reduce energy consumption, rerouting packets, something should be there. The scalability, more number of sensor nodes deployed, routing schemes work with huge number of sensors, routing protocol scalable enough to respond to event in the environment, as I said. Okay, so in one place, you're deploying 1,000 sensors. It is working for years together. And after some time period, out of 1,000 sensors, 500 sensors failed. So the network will operate with 500 sensors. Previously, it operated with 1,000 sensors. Now it's operating with 500 sensors. Now you are deploying another 1,000 sensor in that region. So now it becomes 1,500 sensor. Then also the network has to operate in a perfect manner. Okay, so it should be scalable. So whether the network size is reduced or it is enlarged, whatever it might be, increased, whatever it might be, the network should be there. So it should be scalable. Network dynamic. Routing messages from or move from node is more challenging. Issues on routing and the topological status. Okay, this is happens because everything is a hop by hop. Everything depends on the every data transmitted depends on a nearby node, the condition of nearby node. So it's a dynamic network. The transmission medium. So required bandwidth of sensor node will be low. It's a very low sensor, very low bandwidth in the order of 1 to 100 kbps. And mostly it makes use of TDMA and CSMA. It makes use of carrier sense multiple access protocol, and it makes use of TDMA. So the connectivity, okay, it's very thing is high node density sensing network precludes them from being a complete isolated from each other. So as I said, the network should not be left with any dark patches. So the connectivity there should be there for a lifetime period in that case. The coverage of the entire region. And the data aggregation, we already talked about this data aggregation. And the quality of service. Even in the quality of service, this conservation of energy is highlighted. So that is the main quality of service QoS parameter which is taken in that case beyond the data transmission and all. Right. So in this case, this is the architecture for the wireless sensor node. So we have the sensors, we have the CPU, we have the transmitter, and we have the battery. This is how it will be, right? And now we are going to see some of the hardwares, okay, some of the sensors in that case. So the sensors, these are the we can say this as a companies, or we can say this is the Berkeley or not the company, Berkeley or the university. So these are the people who manufacture the sensors. Okay, so RSC and Berkeley, MIT is having its own sensor model, and everybody is having some sensor models in that case. So out of this, the Berkeley modes are famous in that case. Okay? So this is Rockwell's sensor, just for a glimpse. So what is the capability of a sensor? Okay? So this is the Rockwell sensor as such, wireless sensor node in that case. Okay? So it's a strong ARM processor, 1100 processor, operating in 133 megahertz. Okay? So what is the capability of memory it is having? 4 MB flash memory and 1 MB SRAM is there. Okay? So it has a what can you say, reasonable minimal memory capability, and also the processing speed. And the sensors, coming to the point, sensors, it has various sensors like seismic, acoustic, magnetometer, accelerometer, the temperature sensor, the pressure sensors, and all this. See, so 1, 2, 3, 4, 5, 6. So it is having 6 different varieties of sensors in that case. So all the sensors were implemented in this. So RF communication is 100 kbps, 40 channel. It's a communication. So this is the Rockwell sensor, and this is the Berkeley Mote, which I say, and you can easily find from the size of the Berkeley Mote. You can see, so it's a penny, and the Berkeley Mote is slightly bigger than that penny. That's all. So that is the size of a Berkeley Mote. Okay, you can think of this. Okay, so it is having a. This is operating on tiny OS. It is also having temperature sensor, light sensor, humidity, pressure, 3-axis magnetometer, 3-axis accelerometer, and everything. And it is operating with the Atmel microcontroller. Atmega microcontroller in that case. And this was the family of modes in different years. It is in 1999, and this is in 2000 and 2001. This is in 2001 dot, which is smaller one, and so on. Okay. See, so taking this as an example, okay, the Mica Mote. Mica Mote is one efficient sensor node. It's rectangular in size, and it is 2.25 cross 1.25 by inches. In centimeters, it is 5.7 centimeter cross 3.18 centimeter cross 0.64 centimeter. So maximum it is 5 centimeter. It's a 5 centimeter size. You can imagine how small it is. It is placed on top of 2 AA batteries. That is the life power it is going to get. It's 2 AA battery is the life power it is going to get in that case. Okay. So the capability of Mica Mote. The Mica Mote uses Atmel Atmega 128 processor running at 4 megahertz speed and 8-bit microcontroller that has 128 kilobytes of onboard flash memory. Okay, so this is very minimal, but if you compare this CPU is powerful as 8088. So you can easily compare this. See, what is 8088? That 88 microcontroller, that might be a what can I say, onboard controller in one point of time. Okay. So your CPU is powerful as the 8088 CPU found in the original IBM PC. Okay. So once the IBM PC is powered with 8088 CPU. So this Mica Mote is having that equivalent power. So the CPU of the Mica Mote is powerful as 8088 CPU. Okay, so it is. So you can also say in this manner, you cannot claim it is very less in compatibility. You can claim that every Mica Mote is a IBM PC. Okay, so every Mica Mote is as equivalent as an IBM PC, right? So like that we can also say. So the big difference is that the Atmega consumes only 8 milliamps when it is running and 15 microamps in a sleep mode. Okay, so this is the real attractive feature of this Mica Mote because it's consuming less. It's consuming very less in that case. Okay, so even with full operating condition, it is consuming 8 milliamps. Okay? And it in the sleep mode, it's consuming 50 microamps in that case. Okay, the low power consumption allows the Mica modes to run for more than an year with 2 AA batteries. So with that power, 2 AA batteries, this Mica mode is capable of running for an year, more than an year, depending upon the activity. So a typical AA battery can produce about 1000 milliamp hour, 1000 milliamp hour at 8 milliamps. Okay. So with full operating condition, that Mega would operate for about 120 hours. That is, if it continuously transmit the data, if it continuously transmits some data, it operates for 120 hours. That might be the life period. That is the maximum crucial life period of the Mica Mote. But in case, if it is in sleep mode, okay, if it is in a sleep mode, what will happen? This lifetime extends. CPU sleep mode much of the time, allowing it to extend the battery life considerably. Okay. For an example, okay, so this might be the cycle of a sensor. Okay. For an example, a mote might sleep for 10 seconds. Okay. Even then, if it is a regular waking mode and checking the environment, it does sleep for 10 seconds and wake up and check the status of the environment for a few microseconds. Okay, this is enough because it will wake up, it will come from the sleep mode, it will wake up, it will check what will happen to the first sensor, the second sensor, third sensor, fourth sensor, whatever. All the sensors data will be checked, and if all the data are intact, it is not above the average, it's not above the threshold value, then it will go back to the sleep mode. Okay, if you think this is the cycle of this Mica Mote for a particular application, for example, right? So it sleeps for 10 seconds and wake up for checking up the status for only few microseconds and then go back to sleep. There is no transmission also in that case. If in case, if there is something happened beyond the threshold value, you are going to transmit the value. You are going to transmit the data, right? At that point only, you are going to take 8 millivolts. But in all other cases, it is going to be in a microvolt because you are sleeping for the time period. So if you check this, you can easily understand that that energy with 2 AA battery will last for a year because we are spending the energy only for checking the status, because that point only we are waking up and we are not transmitting also. If at all, if something is there, we will be get transmitted for that moment. That's all. So in most of the time period, we are in the sleep mode. So this is how our modes are extending its life cycle. The same thing, but just repeating in that case. So the capability of Mica Mote has a radio range of several hundred feet and can transmit approximately 40,000 bits per second. It's quite sufficient or efficient transmission. So when it is off, the radio consumes less than 1 microamp. When receiving a data, it consumes 10 milliamps, and when transmitting, it consumes 25 milliamps. So this is the range. So this is the Mica Mote. This is how the Mica Mote will be in this case, but it is quite bigger. This is one of the mode which is of reasonable size, but we are having some other modes with very small in size in that case. See, it's like a penny. This Mica Mote is very, very small in the size. Okay? So this might be a type of magnet. Okay, let it be. Every node is a router and a data source. We already discussed about this. Nodes are severely resource constrained. We explained in that case. It is operating in rapidly changing topology, may contain thousands of nodes, resilient to failures of individual node, and it is self-organizing. Right? So what does a wireless sensor node do? It does monitoring the environment. So sensor data has geographical context. Identity of individual node is unimportant here because we are concentrating on the data. What happened in that particular environment? What happened in the region? what is the value of that particular change. So we are concentrating on the data. We are not concentrating on who sent those data. Okay? So the identity of the individual node is unimportant. It will sense and it will send the data, and the data is important in that case. So data-based, data-driven activities. Okay. So the applications, even in this particular topic, while discussing about this topic, I gave you so many applications like military, habitat monitoring, and disaster management. There are so many things I gave you as an example. So this is listed here: environmental monitoring, military surveillance, emergency, and disaster management. Okay, so disaster relief applications, environmental control and biodiversity mapping, intelligent buildings. So these are all coming into picture as an application. Apart from the crucial applications of wireless sensor network, for which it is manufactured, or nowadays we are making use of this wireless sensor networks for some luxury applications also, like intelligent buildings. So all the equipments in your house will have a sensor node, and this sensor node will operating in a collaborative manner, self aligned manner in that case, and it will be giving the data to a one particular node, and it will be connected to the internet and in cloud, and you can get all this data in your handheld mobile or laptop, and you can even control that. So everything is happening with wireless sensor network. It's a cloud computing right now in that case. Okay, so this wireless sensor networks and wireless sensor nodes are the crucial part where it is starting with. So it's sensing the data. Apart from sensing the environment, now it is going to sense the activity of the gadgets in that case. Okay, so each and every gadget will be implemented with a sensor node. So that operations will be transmitted, and those transmitted values will be given to your handheld devices. So it will become a intelligent building in that case. Okay. Mission surveillance and preventive maintenance, uh, precision agriculture, even that is a main region of application. So you can easily find what is the humidity, what is the water quantity which is needed, when you have to have the pesticides. Everything will be uh, monitored and controlled without the intervention of the human, and you can grow the crops in a better manner in the case of precision agriculturing. Medicine and healthcare, it's a very vital application of every application is a vital application, and this is being dealt with the human lives. So tracking a human, tracking and the vitality of the human by the sensor nodes, and even, what can I say, even that human may not know he is going to uh, something is happening bad to him, but the sensor node will sense all those things, because we doesn't know uh, what the pulse rate right now. Okay? We doesn't know, and and as this COVID situation, they are talking about PSO2. Okay? No people will know how much PSO2 they are having. Okay? So that PSO2 will fluctuate. It has to be 95, 97, 9, or 100. But in some time period, it's just reducing to 40. But we doesn't know. Just we'll feel that something is gliding. We are having some glidiness, that's all. But we doesn't know what is the PSO2 level in that case. But it can be monitored with this sensors. Okay? So if you have a pulse oximeter, and it is capability of transmitting the data to the nearby base station, or to the doctor who is monitoring us, so he can get the data even before you realize that happening to you. Okay? The pulse rate or PSO2, whatever it might be. So the medicine and healthcare is a very great application of WSN, and it's a boon to have wireless sensor applications to medicine and healthcare, and tracking everything. So this is just a limitation. Just we have some of the list here, but we have n number of application, the huge application for wireless sensor network in that case. And finally, with the protocol stacks. Okay, so what are the layers we have to? Now I talked about the physical layer. As such, I talk about the physical layer. Okay, so what is the node? How it is physically made? What is the transmitting capability? What is the battery power? How it is there? What are the applications can be done? So I just talked about the wireless sensor network physical layer, and even not fully about the physical layer, right? But the major layers are data link layer, which is having the MAC in its, okay, how it is going to be get transmitted, medium access, how it going to have, how it going to reduce the energy, and so many things are there in the MAC layer, and even in the network layer, transport layer, and application layer, along with the power management plane and connection management plane and the task management plane. So this is the protocol stack of WSN. And as such, if you talk about the WSN, it is a very long process in this case. So I thought we can conclude with this right now. So with a thing that I gave you a glimpse of wireless sensor network. What is a wireless sensor network? What group is working behind this wireless sensor network? How it is differentiate itself from the Adhoc networks, and what are the key changes of the wireless sensor network from the Adhoc network? Both are wireless. Okay, both are wireless. Adhoc and this are wireless. So how it is differed from Adhoc and this wireless sensor network become a unique protocol in that case. So I explained you and I gave you some idea of where and all it can be used, and I gave you some idea of how really the nodes will be and how small it will be, how it can be deployed, how it is going to work, and so on. And still, if you want to talk, we can talk about the data link layer, network layer, and so many other layers in full. But as the time constraint is so, I'm limiting my talk to this level. And this is about the wireless sensor network in brief. Okay. In particular, we can see in some other time period. And with this, I am completing my session in wireless sensor network, the webinar of wireless sensor networks in this case. Thanking you all for your patient listening, and hope we'll meet in some other webinar with some other data in that case. Thank you. Thank you very much. Thank you all. So far, we discussed about the wireless sensor network, and I have an happiness that I gave a brief introduction about the wireless sensor networks, and what are the groups, what are the task groups which is behind this wireless sensor network, and how it is formulated, and how it differentiates itself from the Adhoc networks, because both are mobile, okay, both are the wireless modes, and how it differentiates itself and made it unique in wireless sensor network from Adhoc network. And all those things I gave, and I also have the happiness of giving you that how really the hardware will be, and what are the complexity in that case, how it is deployed, and everything in that case. So everything pertinent to an introduction and with some physical quantities. But as we know, as we saw in the last slide, we have a protocol stack with all the other layers also, with MAC layer, which is a very important layer, which is in the data link layer, which will talk you about what is how you are going to access the medium in that case. So that is an important layer. So all these things can be taken as another session in that case. So I'm going to complete this session with this glimpse. Hope you all enjoyed this session and have an idea of what really the WSN is, and what are the applications of it, and you might really appreciate what are the applications of WSN and what are the venues it is opening for research and all. So with this, I'm completing the session, and thanking you all for the patient listening, and I'm thanking you all. With this, I'm completing this session. Thank you. Thank you very much.
Give thanks for little and they will find a lot. Honorable Chairman, Managing Director, and respected General Manager Development, I will be here to thank all the coordinators and our management people for organizing this webinar in a successful manner. First of all, I would like to thank our beloved HOD and our beloved principal to organizing this event in a successful manner. My hearty special thanks to our resource person Dr.V.JAWAHAR Senthilkumar for his wonderful presentations on wireless sensor. The word you put out this section was excellent. In future scenario, we can implement this. Next, I would like to thank our participants for spending their valuable time with us. Without you, we can't execute this webinar in a successful manner.